Ready? Yeah, yeah. Hmm. And just give me a confirmation on the audio. Hey, hi, my friend. Here I am back with the IPMAT Indoor MCQ section of 2020. So you might be kind of aware what was the pattern last year, right? So it was very different from usual earlier years. It was a kind of a different one. What we had, we had we had 10 questions of there were 10 questions of short answer type, and there were 20 questions of the MCQs. These are both from the Quant. This is the short answers, right? And you have the 20 questions on MCQ. Then you had 30 questions on the language skills, right? That is English verbal ability, right? So this was the pattern, and each section was given about 30 minutes. It was a 90 minutes paper all in all. Therefore, each section was given about 30 minutes time. So today we will look at this particular section where we were given 20 questions and about 30 minutes of time was presented for us, right? This is the section I was talking about. Say, what was the cutoff for this particular section last year indoor, right? It was about 26 marks, if I remember it rightly. The sectional cutoff for general category was 26 marks. So each question is what, about 4 marks. When you say that what is the correct answer, correct if you answer it correctly, each question carries about 4 marks. So if I say that 26 marks was the cutoff, so technically solving about 7 questions, so that is about 28 marks. So which means even had I attempted about 9 questions and got 7 correct and got 2 incorrect, still I would have cleared the cutoff. So, or technically speaking, 7 good attempts, all 7 right, or the better sense, about nine questions, maybe 7 correct and 2 incorrect would have still taken us to made us clear the cutoff. Right. So keeping that in mind, basically what? So just about, hey, if there are 20 questions, pick half of them. And the idea should be about pick that 50% of them right and try and work with those 50% of the questions. So I will take you through to illustrate that, hey, what best somebody should have done on this particular paper in about 30 minutes time, because the time we have to consider two factors. There were 20 questions and there were 30 minutes, how somebody should have done it. Lesser spoken skill. So what we do here is, out of these 20 questions, there were 15 questions on quantitative aptitude, and there were 5 questions on data interpretation, right? So data interpretation I'm not touching today, because generally most of us do not touch the DI. We will be pretty occupied with quantitative ability. Assuming that, okay, we are still occupied with quantitative ability, still how do we go about and look at this particular section? Because sometimes, because of the paucity of time, it's only 30 minutes, we may not get sufficient time to look through the data interpretation as well, although it was a simple table representation of the data. So most of them might not have find time unless they practice data interpretation really, really well. So probably all right now, those who are in favor of data interpretation, those who are good at calculation, might have attempted those questions. Otherwise, more or less, more majority of them would have attempted the quant questions. Assuming, all right, my battlefield is 15 questions, I may have to do about 9 to 10 questions. Right? Let's take a look, all right, now how these 9 to 10 questions were quite easily doable. In fact, about dozen questions, how easily they were doable in about 30 minutes time. That's the illustration that we are going to have already in some time from now. So this is the background to this particular paper. So therefore, let's go through and find out that, hey, which are the questions that we should have attempted, which are the questions we should have parked it aside. So let's take a look through that. See, technically, even before I do that, it's wise to do the paper in 2 rounds. Right? If you ask me, hey, what is the better strategy to do this particular paper, it would be really, really wise to attempt this particular paper in about 2 rounds as a 2 round strategy. In the first round, pick up those particular questions which you can immediately respond without much delay. In the second round, pick up those questions which you can respond with a bit of delay, in the sense, okay, it is going a little deeper. Probably you may have to think a little deeper. So answer those particular questions. Take such questions in the second round. Maybe keep aside few questions which you should not touch during the course of the exam. Right? These are the things that you should technically keep in mind while doing this particular paper. Therefore, I will show you, hey, what should have been the first round question, what should have been the second round question if this particular paper was presented to us. Right? Of course, the first round, second round questions will not be put in front of us right like one after the other. So like, which means for first few questions are organized as first round question, the next few questions are organized as second round question. Definitely not. You may have to identify those questions as you go along. So that could be a good, therefore that's another skill that you may have to kind of learn. But here in this paper, I kind of organized them. All first round questions, I kind of brought them together. Second round questions, I parked it all a little aside. Right? So let's take a look at these particular question with this perspective. So here we go. There was one simple question on functions. He said that f of x is nothing but this. And then we had g of y, which is nothing but another function. Technically, he defined two functions. One function in terms of another function. Technically, what he has done is he has defined two functions. Whereas f of x, he defined g of y, he defined in terms of f of y as well. Technically, therefore, if I write g of y in entirety, what is g of y? G of y is equal to 2y. Okay, what would be f of y here? F of y, which means I have to refer to f of x. F of x is x square plus log x to the base 3. Therefore, f of y, all it would become y square. I'm just representing this. Hey, this wherever the place of x, it should become y here, y square plus log y to the base 3. This is what I need to substitute in this particular place. Therefore, you would say that, hey, it is y square plus log y to the base 3. This is what you technically have in front of you. So done. So he's asking that, why don't you tell me g of 3? All right, now such a simple nut. All right, he's asking that, hey, tell me the value of g of 3 out here. Fair enough. G of 3 is nothing but here in place of y. Put the value of 3. Therefore, you had 2 times of 3 plus 3 square plus log 3 to the base 3. Right? This is the function. We have it in front of us. So that's the output technically. So therefore you say 6 plus 9, which is 15, plus log 3 to the base 3 is nothing but what? So we all know the simple logarithmic definition. This is nothing but 1. So we have the answer as the 16. Pretty simple nut. So now think about this. So when you say, hey, you have to do attempt about 10 questions in about 30 minutes, you are talking about the average time being about 3 minutes per question. Honestly, trust me, already this was a sitter which should have taken just about a minute's time. So of course, this was not right in front of you in the beginning to look for. So it was there. So when you are doing a 2-round strategy, these are the kind of questions that you are trying to pick in the first round. Technically, what I'm trying to say is, hey, this is what you are picking in your first round, right? Okay, let's take another one. Let's take a look at another one. In fact, I will do all 15 questions for you. So we will do all 15 questions here. All right, all 15 questions, we'll do it together. All right, here another one. See, on the face of it, this does not look like a great question to solve on the face of it, right? When you look at this, hey, does it sound like a great question to solve? Of course not, right? So you have x lying between 0 and 1. What is that author trying to say? So therefore, he's saying that, hey, is this better or is this better? Comparison, right? Technically, you have two things to compare. If I were to say all of them, see, if you look at this entire column, it is the same. It is 1 divided by 1 plus x on one hand. On the other hand, you have x square minus x plus 1. It's the same. It's the same. X square minus x plus 1. It is the same, right? So basically, you have these two elements on the side. So you need to compare which is better, which is not better. That's the whole idea, right? Now, this is one function you have. This is another parameter you have. You need to compare in the given region, right? This you need to compare in the given region. What is the region? He said that if the x is a proper fraction, what kind of proper fraction? Proper fractions are what? Proper fractions are where numerators are less than denominators, right? So two ranges. So in two questions he said that x is a positive proper fraction. Here he's saying that x is a negative proper fraction, right? Positive proper fraction and negative proper fraction. Fair enough. Let me take a positive proper fraction because it's a range. It should work for all the values. Beautiful value is what? Put x is equal to 1 by 2. Is 1 by 2, 1 by 2 lies between 0 and 1? Of course, yes. So therefore, all right, the best way to work with this particular question is what? Take the value take the value as 1 by 2 and substitute. All right, let's try it. Let's try it, and then we will find the comparison out there. So because answer options are saying that 1 with 2 is correct, 2 with 4 is correct, so that's what he's saying. So therefore we may have to evaluate the statements here. Let's take this as 1 half. All right, let's take this as half and try and evaluate. 1 divided by 1 plus half on one hand, right? So when you simplify this, this would become 2 by 3 on one hand. On the other hand, okay, this is 1 square, this is half square, because you took x is equal to half, right? You are substituting this half square, all right, minus half plus 1, right? This is what you have there. Fair enough. Therefore, this is nothing but 1 by 4 minus 1 by 2 plus 1, right? Essentially, what is this? This is nothing but 3 by 4. Okay, so on one side you have 2 by 3, on the other side you have 3 by 4. Which is better? 3 by 4 is better. So where is he saying that 3 by 4 is better? Here, this is the equation. This is better. This is what author is saying. This is better. Therefore, you say that, hey, 1 is definitely sure. All right, 1 is sure. For true, all right, 1 is sure. Now think about it. Just go to the answer options, my friends. Right, that is 1. See, if 1 is true, then the 2 is not true. If 1 is true, 2 is not true. Think about it. 1 is true, 2 is not true. It is the same value, right? What is 1 plus 1 by 3? Nothing but 2 by 3. Hey, what is this particular value? Because here also I will take the same x, because x should lie between 0 and 1. So it is 3 by 4. If 1 is true, then 2 is not true. You don't have to check that fact, right? Common sense. If 1 is true, 2 is not true. Therefore, this option is ruled out. I look for 1 first. 1 is correct. But along with, can 2 be simultaneously true? No. All right, simultaneously it will not be true. So therefore, now look for the choices wherever 1 is coming once again. 1 is coming here, right? 1 is coming here. It has to be true, because 1 has to be true. There is no choice in the matter. B cannot be the answer because there is no 1, because statement 1 does not feature in choice B. Statement D is not true because because statement 1 does not feature in the choice D. Therefore, there is unanimous. There is only one choice left, C. So which means technically just one. So one question you would have done and you would have got your answer. Nothing beyond that. How much? Just one question is all that you could have kind of resolved in this particular paper. One statement and you got the answer. Sitter, right? So sitter, it just takes about a minute or minute and a half, because this is not asking you to solve full. What if even if it is asking you to solve full, still you don't need beyond 2 minutes, isn't it? Yeah. Okay, let's go to the next one. Let's go to the next one. Therefore, sometimes the approaches will play an important role. Yeah, what is my point? What is that I'm trying to tell you? At times, the approaches may play an important role. All right, let's take a question on pure logarithm. We already had one part on logarithm, log 3 to the base 3. We got it as 1 in between. And here we have a question on pure logarithm. Let's try and see this, how this works here. Log anti-logarithm is all you got to take, which you all would know, right? Log, let me copy down. X square minus 1 is equal to 0. In logarithm, what do you learn? Base is always base. What is the statement on logarithm? We say that base is always base. Hey, what do you mean by base is always base? Something like this: log x to the base y is equal to k, let's say. So now, what is the base of the logarithm? Y. Now, if you take an anti-logarithm, what you get? X is equal to y raised to power k. Okay, what is the base of this exponential function? Y. So therefore, base is always base. This is the anti-logarithm. Basically, what you have taken is anti-logarithm. If given that log x to the base y is equal to k, log x to the base y, what did you say? Base is y. So same way, you say that, okay, here also base is always base y, and again the base is always base. Apply that. So therefore, you push it here, 5 raised to power 0. Take one anti-logarithm. When you take the first anti-logarithm, all that you will get, say that, oh, this log goes off. Therefore, you say that log x square minus 1 is equal to 5 raised to power 0, nothing but 1. What is 5 raised to power 0? Nothing but 1. Right? So take another anti-logarithm on this, take another anti-logarithm on this, another anti-logarithm. So now you say that if I take another anti-logarithm on this, So this log will go off. Therefore, you say that x square minus 1 is also equal to 8 raised to power 1. Well, it would be equal to 8 raised to power 1. Right? Okay, nothing but 8. Therefore, you say that x square is equal to 9. If x square is equal to 9, x is equal to plus or minus 3. Plus 3 is also fine. Minus 3 is also fine. Therefore, look at the way he has worded the question: possible. Tell me one possible value of x. Tell me one possible value of x. He's saying one possible value of x. Sure, plus or minus 3, because there are two values. Author has mentioned one value, 3 has been mentioned here. Therefore, we will go with 3 out here. Right? Okay, you are following me. It's pretty simple question. You just have to take anti-logarithm 2 times. Such an easier question. Just that fundamentally we need to be solved. Fundamentally, we don't have to be deeper like IIT JEE kind of test. Of course not. Fundamentally, we need to be solved. We need to understand a little bit of basics of algebra. Right? All right, let's move in here. Let's move in here. Let's take a look at this question. The equation of a straight line passing through the point M. The point is given there, the coordinate axis, such that the portion of it between the axis is divided by the point M into two equal halves. Yeah, comprehension may take a hit. Yeah, you may have to read it second time basically at times in the exam. That's fine. Long sentences, because there is no full stop, nothing, so only the commas. What they do, all of that, such kind of, when you try to write a complex or compound sentence, what happens? Comprehension takes a hit because it's pretty long question. Yeah, sure. All right. Now, such long sentences come in, read 2 times, because short sentences are always easy to understand faster. But yes, at times they intentionally give long sentences. No worries. So whenever they give the long sentences, let you spend little time, or let you spend little time to comprehend that particular question. All right. So you read 2 times. Let's say already you understood the question. Nevertheless, let me explain. What author is trying to say is, okay, on the coordinate axis, there is a point. All right, there is a point called minus 5 comma 4 somewhere here. All right, somewhere here could be that particular point minus 5 comma 4. There is a point called minus 5 comma 4. Okay, so on this particular point, when you try to drop a straight line passing through this particular point, say you dropped a straight line passing through this particular point, this is M, passing through this particular point, it cuts the x-axis as well as the y-axis. It cuts the x-axis as well as the y-axis. Okay, it cuts this x-axis and y-axis equidistant, which means this length is equal to this length. Okay, what are the coordinates technically look like? 0 comma b. Right, generally we write, hey, what will be the coordinate of this point? Let me call this point as q. Right, let me call this point as p. What is the coordinate of the point called p? Right, it would be something like a comma 0. A comma 0. If I find a and b, what do I do here? X divided by so x divided by a plus y divided by b, that is a and b are called as intercepts, right? Intercept form of a straight line, x by a plus y by b is equal to 1. So all I have to find out is what? A and b. How do I find out? By using the midpoint formula. What is the midpoint formula? If you are using the midpoint formula, you would be using this as, okay, a and 0 together, so midpoint formula, and then you collide this with x. What is midpoint formula? Coordinates of x divided by 2, because the ratio is 1:1, because it's a midpoint. 1:1 divided by 2 is equal to minus 4. Therefore, you say that a is equal to minus 10. That's one value. Similarly, you work with the b's here. Once you work with the a's, then you work with the b's. Hey, there is a 0 and b. So therefore, you say that 0 plus b divided by 2. From where the 2 is coming? This 1:1. Right? 1:1, that is nothing but 1 plus 1. Midpoint formula I am applying. So which is equal to how much? Which is equal to 4. All right, that is the y point there, right? So which is nothing but 4. So from here you say that, hey, I got the value of b is equal to 8. I got the value of b is equal to 8. Now substitute x divided by minus 10 plus y divided by 8, which is equal to 1. So multiply throughout by 80, all it you will get the a as the first answer, right? A becomes the answer there. That's a logic. But then, all right, now when we are in the exam, what is the first thing we will do? We know that whatever these are the equation of the straight lines, given answer options are the equation of the straight lines. What we know, if the straight line equations are given, and if this is the point minus 5 comma 4, first thing you will substitute and check, because if it is the point lying on the straight line, what is the first thought that comes to your mind? Hey, let me substitute this and check. So when I substitute and check, if it satisfies, then that is my answer. But the point is, they might have created many equations like that. Therefore, you got to substitute in all four of them and check. That's important there. Fair enough. Let's check it. All right now. So if you, even when you check it, all right now, the value of b is what? 4. Therefore, you are checking this. This is 10 into 4 minus, all right, 8 into minus 5. All right, 8 times of minus 5. Check it. Is that equal to 80? Yes. Right. Therefore, A is satisfying. So check, simply check for the others. Then you realize that the others were not satisfying. In fact, every other equation was not satisfying except A. Therefore, A was your answer. In the sense, okay, I wouldn't have gone through all of this. Not necessary. Even all it, I would have understood this question vaguely, saying that, okay, this particular point lies on the straight line. Let me quickly put my head and check how many of the equations are satisfying this particular point. If only one is satisfying, I am done. All right, now I don't have to go through midpoint formula. I don't have to go through intercept form of a straight line. All that might not be required out there, right? Simple. Okay, that is how technically, all right, the best way, why you am calling this question as a first round question. You would have rather approached this particular question by plugging the value of m in the answer option. All right, therefore I'm saying that, hey, it is the first round question. It's a very natural thought which will come to you. That should not be a concern there. All right, yeah. So this is another question. So now you are appreciating, you are seeing that, yeah, correct. In fact, there are some question. All right, yes, for some questions which can be technically done much faster than you anticipated. All that you got to do is what? Keep your cool. Keep your cool and search for those questions, right? Search for those 10 odd questions, say, where they are hidden out there. So that will do the trick. That will do the trick, right? That's what you got to be doing there. About attempting 50 to 60% of the paper is a very good bet, right, in a given time. Fair enough. Let's go to the next one now. Let's move to the next question. Next question. Okay, these were some of the questions on algebra. Let's see, arithmetic. I have now come to the arithmetic, the round one questions only. I'm still doing the round one question. Take a look at this particular question, round one, arithmetic question. 50 liters of mixture of milk and water contains 30% water. All right, so for first mixture, 50 liters. So how much milk and how much water? So water is 30%. So therefore you say that 15 liters is water. How much milk? Therefore remaining 35 liters. Fair enough. Second one, this mixture is added to 80 liters. All right, 80 liters of another mixture. So how much water and milk in this? The water is 20% water. 20% is 16 liters. Therefore, how much is the milk remaining? 64 liters. Remaining 64 liters. Then, how many liters of water should be added to the resulting mixture to obtain the final mixture which contains 25% water? Now, listen to this. What do you mean by 25% water? What do we mean by 25% water? 25% water means 75% milk. 25% water also implies 75% milk. It is as simple as that. Fair enough. Therefore, milk by water, or water by milk, whichever way that you understand, that doesn't matter. Or therefore, water by milk. Water by milk is nothing but water is 25% and the milk is 75%. And what does not change? This will not change. This is unchanging part, because you are not adding any more milk to this. You are not adding any more milk to this. What is he saying? How much? He's saying how many liters of water should be added, which means you are allowed to add water, but you are not allowed to mix the milk. Fair enough. All right. Therefore, let me write the milk. Milk is the constant part. I don't have a control over 75% of the milk. Milk should form 75% of the mixture here. Fair enough. What is the milk here? 35 is the milk. All right, and the water milk here is 64. 35 plus 64. How much is this? 99. If the 99 corresponds to 75%, 25%, that is one third. What is 25% by 25 by 35? 25 by 35 is nothing but one third. All right, therefore you are saying that, hey, 3 portions corresponds to 99. Therefore, 1 portion should correspond to how much? All right, 1 portion should correspond to how much? 33. All right, it should technically correspond to 33. See, it's a simple way. Whichever way you calculate, from here the calculation was simple. That's what I'm trying to say. Water should become 33. But how much water do I have at this point in time? 15 liters of water plus 16 liters of water. Together, I have 31 liters of water. 15 plus 16, which is 31. I have 31 liters of water. But to make sure that water comprises of 25% of the mixture, how much water is essential? 33 per liters of water is essential. To 31, what should be added so that it becomes 33? 31 plus 2 becomes 33. right? 31 plus 2 becomes 33. Therefore, you say that, hey, 2 liters of water should be added, so that you will end up getting, you will end up having the percentage of water as 25%, right? One of the simpler questions, because all nice numbers. Are you getting any decimals here? Nothing, right? Because 50 liters, you are calculating 30% of it, right? 80 liters, you are calculating 20% of it. Such nice numbers. Even look at the answer choices, they were all whole numbers. So you will love this. All right, now one or the other way, you, without much pressure, you will definitely get the answer to this question, right? Therefore, take the composition of the question. Take a look at the composition of the question. All beautiful numbers, without inducing any pressure. All right, you will get the answer. All you got to do is what? You keep calm. You keep calm. Fight, all right, pick your battles. All right, every battle is not yours. In the sense, every question is not yours. Pick your battles and try to work with those battles. Great. All right, let's take a look at another one. Simple one on partnership. A very simple one on partnership. Ashok started a business with a certain investment. After a few months, Bharat joined him, investing half the amount as Ashok's initial investment. At the end of the year, at the end of the first year, which means after a year, the total profit was divided between them in the ratio 3 is to 1. Now, what was Bharat? When did Bharat join? After how many months the Bharat joined? That is the question. Fair enough. See, what we know, only one concept here: profit should be shared, profit should be distributed, all right, in the ratio of product of investment and the time period, right? Investment and the time period. Profit is a function of, profit is determined, who should get how much profit is determined by two things. All right, now one, it is determined by investment. Second, it is determined by the time period. These are the two aspects which go into that particular question. Fair enough. Therefore, there are two characters here. There is Ashok and there is a Bharat. I will say that Bharat invested 1 rupee, Ashok invested 2 rupees. Is that okay? Because I said that it's a ratio. All right, now you get a ratio here. Therefore, whether you write 1x and 2x, or whether you write 1 and 2, it is fine. But you may wonder that from where you got these 1s and 2s, because it said, or it is said that after a few months, Bharat joined him, investing half the amount. Say that Ashok invested 2 rupees, then Bharat has invested 1 rupee. This is from the investment perspective. Had you taken this as 1 here, then you would have written this as half. All right, you would have written this as half. Write some smart numbers so that you don't have to fight with ratios, etc. Right? I have to maintain that relationship correct. Therefore, I will write 2 here and I will write 1 here, because I read the question. Once you read the question, you can understand what kind of numbers to write. Fair enough. Done. At the end of the first year, which means the year is over, the profit got distributed in this year. What is not given to me? The time period. Time period is not given to me. Let me talk in terms of months. You may wonder why you are talking in terms of month, because answer options are months. Because answer options are months. You speak the language what he wants. Let us not speak the language what we want. Rather, let us speak the language what the question wants, right? Question is asking that, tell me in terms of months. Sure, I will speak in terms of month. So I say that Ashok stayed in the business for how long? 12 months. Okay. So, but B stayed in the business for how long? Don't know. X months. All right, X months. How long did B stay in the business? He stayed in the business for X months, let's say, right? Because he joined later. So therefore, I can't write 12 there. So it is some number less than 12. Fair enough. Therefore, the profit should be distributed in what ratio? Profit should be distributed in what ratio? 12 into 2, 24 is to 24 is to 1 into x, which becomes x. This is the profit sharing ratio. Author said that, hey, this number, this 24 into x, whatever you are writing, is nothing but 3 is to 1. That is what he's trying to say. In the sense, he's trying to say that 24 divided by x is equivalent of 3 divided by 1. This is equivalent of 3 divided by 1. Therefore, 3 one time, 3 8 times. Therefore, x is equal to 8. You are trying to tell that, okay, this guy stayed in the business for 8 months. If he stayed in the business for 8 months, after how many months he joined? The question is, he joined after how many months? He joined after 4 months, because he stayed in the business. Ashok stayed for 8 months. Bharat stayed for 8 months. Ashok stayed for 12 months. Bharat was in the business for 8 months, which means after how many months he joined? After 4 months is when he joined. Right? Simple concept on, because all nice numbers, beautiful numbers. Right? So therefore, this is another sitter that you should have pursued it. Right? Another sitter you should have pursued it. Averages. Take a look at this question, and the beautiful question, averages. And the beautiful question. Take a moment, read this question. Just read it to understand yourself. Yeah, let's take a look. All right, so you might have put your thoughts behind this. Let's take a look. The average marks of 6 students in a test is what? 64. Therefore, what is the total marks of all these folks? You should see, remember, you should always read the full question to understand the intent of the question. Otherwise, the direction in which we want to drive this could be lost, right? Direction could be lost, right? Therefore, keep that in mind. That's the reason I allowed you some time to read through this particular story. So then you understand that, hey, he's interested in, okay, arrange them in the ranks, the small, all it now least value, marks, all it marks wise, M1. Somebody got M1 marks, somebody got M2 marks, somebody got M3 marks, somebody got M4 marks, M5 marks, and M6 marks. M6 being the best. M6 being the best and this being the least. This being the least. Assume just like that. You may say that no, I will say M1 is the best. That's all right. Whichever way that you want. You have some mnemonic, some direction in your mind. M1 being the least, M6 being the most best. Or let's say these are the marks. What author wants is, hey, tell me the difference between these two scores. Tell me the difference between maximum difference, because we may not be able to find out exact values. That's what he's saying. Tell me the maximum possible difference between the second highest and the second lowest marks. So I want to maximize this particular difference, right? That is the sense of this particular question. Right, let's take a look at this. So how do we approach this? First, let's get the total. What is the total marks? If the average is 64 for 6 kids, all right, therefore 64 into 6. That is the total marks, right? So let's get the total here, right? So therefore you say that 384 marks is the total marks. This is the total aggregate total marks. All these six kids, right? Okay, next one of them got 70. Who is this fellow who got 70? Absolutely no idea. It's given that one of the students got 70. One number has come there, right? And there are students who got students have got 40 and above. Now the idea is, if I want to maximize the gap, what is the idea? I need to keep this as small as possible, keep this number as small as possible, make this number as large as possible, right? That's the whole idea. Make M2 as small as you could, make M5 as large as it could become, right? That's the whole idea. That's when the gap becomes maximum. Do that then. Let's do that. Hey, what is M1? 40. No brainer. Hey, why 40? Because everybody scored 40 or above. Fine. Then what should be the M2? 41, man. 41. Why not? Why somebody or something else? 41. What about M3? 42. You may wonder, what is the problem? Why M3 is 42? Because I have a total limitation on the total. Total is 384. Therefore, what if I want larger value for M5? Naturally, M6 also becomes larger. If I want two large values at the end, ensure that you are giving tiny values in the beginning. All right, so that your 384 out of 384, you don't use too much of that capacity in the beginning. So that's what the idea is that you are trying to do. Yes, all right, therefore you gave 40 here, you gave 41 here, you gave 42 here. Now you give this fellow 70. You give this fellow 70 because one of them got 70 marks. It's given. Give that also as 70. Let us reduce it. Hey, so far how much of the capacity is already has been utilized? Add these values. 40 plus 41 plus 42 plus 70. Add those particular values there, right? Which becomes 193. Right, you are using this capacity, all right, which has become 100 and all right, you are using this capacity, all right, which has become 193. Fair enough. All right, therefore how much more I am left with now? 191. So this 191 I need to split between M5 and M6. M5 and M6. I will keep M5 as large as M6 for a simple reason that I want to make this M5 as big as possible. Therefore, I make almost equal M5 and M6 almost equal, although M6 should be slightly larger. Yeah, from that perspective, you understand that, hey, I will make this 95. I will make this 95 and I will make this 96. 95 plus 96 is nothing but 191. All right, nothing but 191. Sure. Therefore, you got 95 here and you got 96 here. Yeah, what is the required answer therefore? Difference between 95 and 41, right? So which would become 54. Pretty simple question, very simple question, nice numbers again. All right, just you got to manage your calm and identify these questions and try to work with these particular questions. All right, let's take another one out here. Let's take another one out here. Okay, now we are kind of getting into the second round, right? Some of you may also disagree. You may say that no, I would have still done this in the first round. Fair enough, based on your strengths and abilities. Well, what I may say as a second round, you may disagree and you may say that it's a second round, but broadly, all right, based on my wisdom, based on my understanding, All right, based on my experience with students, what I'm trying to say is generally these kind of numbers are pushed into the second round. Although they are fine, they're okay to do, they're pushed into the second round for two reasons. One, either they are lengthy and time consuming. On the face of it, you realize that this appears to be lengthy and time consuming, number one. Or you may say that, hey, it is going little deeper, I'm not very clear, I'm not seeing the end from the beginning, I'm not able to see how it will unfold, how this entire thing will unfold. When you are not able to see, that is when you realize that, okay, probably I will take it up in the second round, right? Yeah, clueless about it, you will not touch that question in the exam. All right, clueless means what? I have no time for you, I will get some idea about you after the exam, not definitely during the exam. It's not a research paper there, right? Okay, let's take a look. Let's take a look. In a class, students are assigned roll numbers from 1 to 140. All students with even roll numbers opted for cricket. Or even roll numbers means what? The numbers divisible by 2. All right, numbers divisible by 2, all numbers divisible by 2, and all the students whose numbers are whose roll numbers are divisible by 5 have opted for football, and all those numbers which are divisible by 3 have opted for basketball. Hey, which means think about a number. Think about a number which is divisible by 2, divisible by 3, and divisible by 5. What is the meaning of divisible by 2? If the number is divisible by 2, he will be put into cricket camp. If the number is divisible by 5, he will be put into the football camp. If the number is divisible by 3, already he will be put into the basketball camp. Now you may wonder, hey, there are some numbers which are divisible by all three of them. Of course, yes. Right now, 2 into 3 into 5. Say that the number, one of such number is what? 30. What if 30? 30 is divisible by 2. 30 is divisible by 3. 30 is divisible by 5. Therefore, you realize that, okay, if somebody's roll number is 30, he'll be put into cricket camp. He'll be put into basketball camp. This fellow will be put into the football camp as well. Okay, then you realize, man, this is a set theory question. Why? Because they are putting into different camps. Somebody might have been put only into the cricket camp, somebody might have been put into only basketball camp, somebody only football camp, somebody all three camps, somebody two out of these three camps, something like that, right? Something like that. Fair enough. Therefore you say that, hey, this is a Venn diagram for 3 technically. It's a Venn diagram for 3. Point is, there may be some folks who are not put into any of these camps, right? There may be some folks out of these 140, out of these 140 students, there may be some students who are not put into any of these camps. Hey, are there somebody like that? Yeah, of course, yes. Think about number 7. All right, think about number 7, roll number 7. Assume that there is a character by name roll number 7. All right, now, so he is what? He is now put into any of, he is not put into any of the camps. He cannot be a part of cricket. He can't be a part of basketball. Cricket, because it is divisible by 2. Basketball would be divisible by 3. He can't be put into football because football would be divisible by 5. Now look at 7 here. 7 is not divisible by 2 or 3 or 5. Therefore, that is one number. So that's what I'm trying to tell you. I'm trying to say that, hey, all right, there would be certain numbers. See, for example, another fellow, if you want 13. Let's say another fellow, if you want, there is another fellow called 13. 13 also falls into that particular category, right? Yeah, likewise. All right, now we can think of some numbers. The idea is, oh, which means now should I identify these numbers manually? No, that's the reason I said it's a set theory, right? That's the reason I said it's a set theory. Okay, so what components you have to calculate in this particular set theory? Set theory, you say that numbers divisible by 2 one at a time. So numbers divisible by 3, then you will have numbers divisible by 5, then numbers divisible by 2 as well as 3, nothing but 6, right? Numbers divisible by 3 as well as 5, nothing but 15. Numbers divisible by 5 as well as 2, not 5 as well as 2, nothing but 10. Then you will have numbers divisible by 2, 3 and 5. Numbers divisible by 2, 3 as well as 5. So this is how it kind of all it now looks into set theory formula. So basically I'm getting into the set theory formula. Hey, how many numbers are divisible by 2? 140 divided by 2, 70. Therefore you say that, okay, these are 70 numbers. How many numbers are divisible by 3? You say that 140 divided by 3. You may say 140 is not totally divisible by 3. That's okay. Quotient is enough for us, right? Quotient is enough. Therefore you say that, okay, 4 2 to 4 4 4 3 times 12, 4 4 times 12. 4 3 times 4 4 times 12, then 20, 4 6 times 18, 46. Hey, how many numbers are divisible by 5? 140 divided by 5. Therefore you say that 28 numbers. 28 numbers. Hey, what are these numbers? You are saying that cricket 70. That value of that circle is 70. What is B here? This is 46. Divisible by 3, there are 46 numbers, right? Divisible by 5, there are 28 numbers, and so on. This is what you are writing. Then you will say that set theory formula you understood by now, taking one at a time, blah blah blah, all that stuff. So therefore you will say that 110, all right, 30 144. right? 144. Sum has become 144. Divisible by two numbers. This time it is 140 divided by 6. 140 divided by 6. Therefore, 6 two times. Right, 6 2 times 12, then 20, 6 3 times 23. So here 140 divided by 15, 9, right? 140 divided by 10, all right, which is nothing but 40. 140 divided by 10, all right, which is nothing but 40. Now what do? I will put all of them together. I will add all of them together. All right, 23 plus 9, which is 32. 32 plus 14, which will become 46. All right. On the other hand, divisible by all three of them means what? 140 divided by 2 into 3 into 5. Right. So which becomes 30. All right, which becomes 30. Right. So therefore you say that, hey, this value is nothing but 6. Sorry, this value is nothing but 4. Right, this value, quotient is nothing but 4. What you do? This is with a plus sign. Set theory formula, one at a time with a plus sign. Intersection, this is with a minus sign. And what about this 4? This 4 will come with a plus sign. This 4 with a plus sign. Therefore, add them. 144 plus 4, 148. Out of 148, you are reducing 46. You are reducing 46. Therefore, you are saying that 102. What is 102? 102 people find position on this circle. 102 people find position on this circle. So out of 140, if 102 people find the position on this particular circle, then what happens to the remaining 38 folks? Remaining 38 folks are none of these. Remaining 38 folks are none of these. That is your answer. That is your answer. None of these is nothing but did not opt for any of the three sports. Did not opt for, which means none. They opted for none. Nothing but on the Venn diagram, none. It's a beautiful question on Venn diagram. Might have taken some time, but if you look at already the nuts and bolts of this particular question, what was expected? Division by 2, division by 3, division by 5, right? Division by 6, division by 15, division by 10, division by 30. Such beautiful numbers, right? So it wouldn't have really induced too much of pressure, nor taken a lot of time as well, because it's okay to divide by these particular numbers. Such a simple 3-digit number 140 has been presented to you. Division could have been, all right, now this could have been kind of considered and solved. All right, let's take a look at this question. So again, now this is what I mean by going a little deeper into the concepts. Right now, this question is going up a notch deeper into the concept. See, how do I understand that the conditions, the numbers are acute angle triangles, obtuse angle triangles, or right angle triangles? If the sides of a triangle are ABC, if the sides of a triangle are ABC, if C is one of the largest sides, right? If C, let's say that C is one of the largest sides, then the condition is if C square is less than A square plus B square. Right? If C square is less than A square plus B square, this is the condition for acute angle triangle. What are ABC? Sides of the triangle, not angles of a triangle. Largest side, C being the largest side. Hey, what if C square is equal to A square plus B square? Right? That forms a right angle triangle. Right? What if C square is greater than A square plus B square? This is the condition for obtuse angle triangle. Fair enough, we kind of got this particular understanding here. So now come back to this. This is the condition. After reading this question, this is the condition which pops in your mind. Okay, this is some condition that strikes in your mind. If this does not happen, nothing makes sense from here. Now the second parameter, second one, the number of acute angle triangle whose sides are 3 consecutive positive integers. Now look here, sides are 3 consecutive positive integers, which means something like ABC. All right, something like ABC, C being the largest side. Right, because it's a 3 consecutive natural numbers. Therefore, you have A, you have B, you have C, C being the largest. All right, C being the largest of the sides here. All right, so considering that, let's take a look. Considering that, so which means I can have 1 here, I can have 2 here, and I can have 3 here. What? All right, now, so can I form a triangle using 1, 2, 3? No, because sum of two sides should be greater than the third side. 1, 2, 3 doesn't even form a triangle. Right? Triangle itself is not possible using 1, 2, 3. Let me start from 2. Let me define the values of 2. How many cases 2 can take? That's my point here. A can take 1, A can 2, A can take 2, A can take 3, A can take 4, A can take 5. Hey, like that till where it can take? All right, it can take 98, 99 and 100. This is what you are trying to say there. Right now, A can take 1. All right, A starts from 2, A starts from 3, A starts from 4. Likewise, that's what you are trying to say there. Okay, then finally, perimeter is 100. Perimeter is 100. not sides are 100. Perimeter is 100 means what? All right, now if you divide this, you know that average is nothing but 33. Kind of 33 is the average. Therefore, you say that, okay, can I write the values as 30, 31? Can I write the values as 32, 33, and 34? All right, take a look. All right, no, so which means you went up to 32 from 5, 6. Simple logic in your mind. You are going with this particular one. Hey, this has become how much? This has become 99. Hey, what if I take 33, 34, 35? 33, 34, 35, it will become 102. So therefore you say that, hey, let me not consider this case of 33 at all right, let me not consider this case of 33 at all, right? So therefore 32, 33, 34, you say that, okay, so I'm going 32, 33, 34, you are going up to 99. All right, that value is becoming 99. So at most 100 is what we said, but they should be consecutive natural numbers. Therefore you cannot take 33, 34, 35, right? That becomes 102, because he said that the perimeter should be at most 100. Fair enough. So therefore we are here. All right, we are here with these particular values. Out of these particular values, one is ruled out, which means how many test cases I have? 31 test cases. There are 31 test cases. In the sense, 31 triangles are possible, because first one, 1, 2, 3 is ruled out. Test cases are 31. You are trying to say that there are 31 test cases. What are the sides here? 2, 3, 4. Check about this. For 2 square plus 3 square, and you have 4 square. Now these are the numbers you are checking. Is the now is c square greater or not? These are the conditions that you are checking. Which condition works? Does this work? Does this work? Does this work? That's you are checking here. 2 square is 4, 3 square is 9, therefore it is 13. So therefore this is greater. C square is greater means what? It has formed a obtuse angle triangle, which means this is ruled out. Why? Because it has formed an obtuse angle triangle. Okay, let me come to the next one. 3, 4, 5. Let me come to the next one. 3 square, this is an exciting number. 3 square plus 4 square is equal to 5 square. Isn't it an exciting number? It's a right angle triangle. 3, 4, 5 triplet, we all know. So but then that is not what I'm looking for. I'm looking for c square less than, because I'm looking for acute angle triangles. This is ruled out. All right, this is ruled out. Then you have 4, 5, and 6. So you have 4 square. All right, you are considering 5 square, and you are considering 6 square. Let us check it. 4 square 16, 5 square 25, it has become 49. So what is 6 square now? 6 square is 36. Is 49 greater? Yes. Which means is 6 square lesser? Yes. Is it an acute angle triangle? Therefore yes, this has formed an acute angle triangle. From here everything else will be acute angle triangle. Simply put, hey, I have 32 cases. I have 32 cases. Let's say that, okay, from 1 onwards only you take. If you want to take from 1, take it, absolutely no problem. You have 32 test cases, out of which one case is ruled out, second case ruled out, third case ruled out. So 3 cases you are ruling out of this. Out of 32, 3 cases are ruled out. Therefore 29 of them will make sense to you. They are in your favor, right? 29 cases with 32 minus 3. All right, 32 minus 3, 29 are in your favor. That's the answer to this particular question, right? Let's move to the next one. Let's move to the next one. This is based on the concept of, all right, this is simply based on the concept, this is simply based on the concept of consecutive natural numbers, right? Right. Next one. I hope you are following me, whatever I'm trying to tell. I guess all right, now you are able to follow and you are able to connect with me. Okay. Yeah, these are little deeper issues what we are discussing now, because we were closer to the second round. First round is done. We are kind of like attacking the second round out here. Second round is what we are trying to attack. Let's take a look at this. 1 by 1 square, 1 by 2 square, 1 by 3 square, some value called as k. Let us say that pi square by 16, or let some value. Then you have 1 by 1 square, 1 by 3 square, like this. Okay, therefore only odd, basically you are saying that, hey, odd, which means evens are omitted. 1 by 2 square is gone, 1 by 4 square is gone. Therefore what will be this? All right, therefore what would this become? That is the question we are trying to attack it here. Fair enough, let's try and attack this. Let's try and attack this. So what I have is this. Listen carefully, all of you. What I have is this: 1 by 1 square, 1 by 2 square, right? 1 by 3 square, and so on. Keeps going up to infinite terms. Up to infinite terms is pi square by 6. Right, let's keep this. Then what I want out of this, let me do 2 separate issues out here. So I'm saying that, hey, I'm interested in these particular values. Separate what you are not interested in. I am not interested in this 1 by 2 square, 1 by 4 square, 1 by 6 square, right? I'm not interested in this. Hey, this goes up to where? This series also goes up to infinity. And now what you are left with therefore inside the bracket, 1 by 3, 1 square, 1 by 3 square, right? 1 by 5 square. What did you do? Odds and evens you separated, right? Odds and evens you separate. Odd and even what? The denominator basically, right? This 2 you kept it here, this 4 you brought in here, right? Similarly 1, 3 and 5 you took it to the other side. Where it will go? Infinite terms. Infinite terms. What is the response for this? Pi square by 6. Right? Response for this is pi square by 6. Author is interested to understand what is this. What is this? That's his interest. Fine. Let me call that as x. Let me call that as x. Solid instead of keep writing it again and again. Let me call it as x plus. So therefore, let me pay attention to this. Solid, let me pay attention to this. Let me call this whole thing as x. Let me find out what is x therefore. Or what is the output here, my friends? Output is pi square by 6. So this output, I'm not changing anything there. All right, that output is pi square by 6. So 1 by 2 square, I can write it as 1 by 2 square times of each term. All right, 1 by 2 square, I can take it common because every term in the denominator is even. Therefore, I can take 1 by 2 square common. I will write 1 divided by 1 square. Then I will write 1 divided by 2 square, right? 1 divided by 3 square, and so on up to infinity. Right, up to infinity. This is what you ended up writing. Now come back and substitute. Hey, what is this you got here? This is nothing but what you started with. This is nothing but what you started with. This is what is given to us. Finally, I'm back to this particular bracket is nothing but pi square by 6. Therefore, you say that, hey, this is 1 by 4 times of pi square by 6. Pi square by 6 plus x. Where is that x? This x, which is also equal to pi square by 6. Right, which is also equal to pi square by 6. Now, do I get the value of x from here? Of course, yes. Therefore, x is equal to. So, that's it. All right. Now, very simple question. Just a very typical methodical question, right? So, just a function of the method here, right? Therefore, x is equal to pi square by 6 times of 1 minus 1 by 4. All right, 1 minus 1 by 4. Hey, what is that 1 minus 1 by 4? You have 1 full here and you have 1 by 4 times here. Right? Therefore, 1 minus 1 by 4, which is 3 by 4, which is nothing but 3 divided by 24 times of pi square, right? 3 divided by 3, all right, otherwise, all right, now this is nothing but 3 by 4 pi square by 6. Right, in other words, 3 one time, this is 3 two times, therefore pi square by 8 is the required response to this question. Pretty simple and elegant question, very methodical question. Trust me guys, those who know the method, how long it will take to write this particular line? Say 2 minutes. 2 minutes, which is a very good bet. 2 minutes is a very good bet because on some of the easier questions, you took less than a minute. The beginning, what I have shown, some of the functions question, some of the logarithm question. Now you are coming into the zone where it is taking about 2 minutes, right? With some adequate practice, this question might have costed you 2 minutes, which is a good range. Which is a good range. You are getting about 30 minutes. Already, some questions you solved in less than a minute. Some questions you are taking closer to 2 minutes. There may be some questions which we will take closer to 3 minutes. All this put together, you will be technically able to solve about a dozen questions, right? So good attempt. Even the 9 would be good, but then I would rather say that, okay, about a dozen questions you must be able to solve all it if you just adequately prepare for this paper. Right, here we go. The next one based on the numbers. We go here. Next one based on numbers. Probability that randomly chosen. See now again. So what is happening in the deeper questions is multiple concepts are coming together. What is that? Numbers is coming alongside probability. Right, so this is what happens, right? Technically in a deeper concepts, so they mix one or two concepts together. So that is one way of making it little confusing or little deeper. That's one way, right? The other way is what? Other way of doing it is what? Take the just question itself little more deeper, right? These are the two techniques, solid kind of they are the techniques solid that they use. Bring multiple concepts together, mix them and give it as a question so that it becomes a little confusing for the students, because some of them may be good at numbers but not so good at probability. Some of them may be good at probability, some questions built on probability, concepts of probability, but not good with the numbers concept. Then what happens? They get handicapped by this. All right, naturally they get kind of handicapped. Fair enough. All right, now let's take a look at this. What is he saying? The probability that a randomly chosen factor of 10 raised to power 19 is a multiple of 10 raised to power 15 as well. All right, 10 raised to power 19 is 10 raised to power 15 as well. Okay, 10 raised to power 19, factors of 10 raised to power 19. First, what you will do, you write this as 2 raised to power 19 and 5 raised to power 19. Then you find the factors of this. How do you find the factors of this? Hey, therefore, what are the factors of 10 raised to power 19? The factors are nothing but 19 plus 1, which becomes 20. Another 19 plus 1, which becomes 20. You are saying that, okay, there are 400 factors for the number called 10 raised to power 19. Okay, right? How many of these factors will be multiple of 10 raised to power 15 also? Therefore, how do you write? You say that, okay, in that case, I want to write 10 raised to power 19 as 10 raised to power 15 into 10 raised to power 4. This is how you would have written this, because you want this to be a multiple of 10 raised to power 15. Right now, therefore, you write 10 raised to power 19 as 10 raised to power 15 and 10 raised to power 4. Now, develop the factors for this. Now, you say that, okay, this is nothing but 2 power 4 into 5 power 4, because it should be a multiple of 10 raised to power 15. Therefore, what you can only play with 10 raised to power 4, right? You can play with the number of factors of 10 raised to power 4. So therefore, you say that, hey, how many factors therefore? What is the factors of 10 raised to power 4? Because now you're focusing on this. So this 4 would become 5. Well, this 4 also would become 5. So therefore, you are trying to say that 25 are in your favor. All right, 25 are in your favor out of what? Out of 400. Out of 400, 25 are in your favor. Probability. 25 are in my favor out of 400, which is nothing but 1 divided by 16. Right, 1 divided by 16 is the required response to this question. Right, yeah. So what we did here, we brought the number of factors concept from the numbers. We included it into probability, right? Probability was the last mile. It was just a last mile. The major concept which came into this particular question was what? Numbers. Therefore, I also put it in that order. Numbers first, probability next, right? Okay. Let's move to the next one. Let's move to the next one. I hope you are getting the perspective on this. All of you are getting a perspective on this. Let's move to the next one now. Right. Take a look at this. This is Bayes' theorem. All right, so if you kind of remember, it's a Bayes theorem. Otherwise, simple logic can be used. Of course, all these theorems are built on what? Certain logic. So let's understand the simple basic logic behind this particular question. A man is known to speak the truth on an average 4 out of 5 times. He throws a die and reports that it is 5, right? So which means he doesn't tell the truth all the time, right? So but then yes, majority 80% of the time, he speaks the truth, but once in a while he lies. That's what he's trying to say. Once in a while he tries to cheat. Right? He throws a die and reports that it is 5. So can I believe this? What is the probability that it was actually 5? Because you know that you already know this guy lies once in a while. So therefore you will get the doubt. Should I believe? Already know, should I believe? Then what is the probability that I should believe this? Right? Two parameters come in the picture. Right? Two things come in the picture. Number one, with respect to die. Alright, with respect to die. What is that? 5 as an outcome. 5 as an outcome versus other numbers as an outcome, because outcome can be 5. 5 is in your favor. What are the other numbers? 1, 2, 3, 4 and 6. These 5 are the other side. So this is what can happen with respect to die. With respect to die, you are trying to say that 1 out of 6 are in my favor. That's a probability of being 5. So because actually of 5. Actually 5 means what? You are working for 5. If you are working for 5, then the probability in your favor is 1 by 6. What is the other side? It is not a 5. It is not a 5 is 5 by 6. Probability that the number is not a 5. You rolled it. Probability that the number is not a 5 is how much? 5 by 6. All right. Yeah. That's about the die. About his truth. Truth or lie. No, about his report. He reported something. What about his report? The report that it is a true is 4 out of 5. 4 out of 5 times he reports the truth. Already it's given. 4 out of 5 times he reports the truth. How many times he reports a lie? 1 out of 5 times he reports a lie. 1 out of 5 times he reports a lie. Right? Okay. So put them together. Therefore, put them together. What is in your favor now? What are you in favor of? I am in favor of finding the probability of getting a 5. Probability that it is actually 5. Which means how it happens that it is 5. It is 5 and he reported the truth. All right, that's what you are writing in the numerator. It is 5. The dice has shown the 5 and the fellow has reported and the fellow has told the truth. Right? That's in your numerator. What is the denominator? It is 5. It is 5 and the fellow has told me the truth. Fellow has told me the truth. Or means plus. Or means plus. It is not 5. It is not 5. What is it is not by? For not 5. 5 by 6. It is not 5. And he lied. He lied by saying that it is 5. It is not 5, therefore, but he said that it is 5. Already he reported that it is 5. So which means he lied. No, that is in the denominator. This is technically a function of the base theorem, right? Now this structure what we wrote is nothing but a part of the base theorem, but not required. Already it's a simple logic, What is how did we think about this particular question? It is 5 and he reported the truth. It is not 5 and he reported a lie, That's it. All right, now that's all the way of thinking. That's in the denominator. Two portions in the denominator. All right, two portions in the denominator, one portion in the numerator. The favorable portion is in the numerator. Okay, what is in the denominator? It is solid. Now it is 5 and he told me the truth. It is not 5 and he lied me saying that it is 5. All right, therefore he lied. So what is in the numerator? Numerator is the probability that it is 5. All right, now it is 5. That's a favorable part. So therefore already when you resolve this, you get the answer as 4 divided by 9. All right, pretty simple, straightforward question. All right, it is nothing but 4 divided by 9. Simplification. Right, I hope you are getting the perspective. It is very simple. Technically speaking, it's a base theorem. But of course, all right, without really unknowing that it's a base theorem, we could have still solved this particular question. That shouldn't be a concern. Right, let's move to the next one. Right, a question on trigonometry, the value of cost. All right, these are the ones which are going technically deeper. All right, now it is, all right, now you do it or not depends on how well you understand the trigonometry. Fine, you did a fair bit of study of trigonometry in the 11th 12th standard. Good. No, I have not done significant study. That's okay. All right, now it depends on how much study you have done. There is no hard and fast rule that you must have done these kind of questions. No, but it's my duty. I will show it to you. But then yeah, some of them you had a choice. Now we are entering that particular zone in the second round. Based on your strengths and weaknesses, you can have a choice, right? Trigonometry is my strength, you can do it. Hey, trigonometry is not my strength, you can leave it, right? You have a choice. Basically, when you're doing these kind of questions, you have a choice out here, right? Even the previous question, hey, that one on the base theorem that we did, no, I'm not very comfortable with that. You have a choice, right? Yeah. So earlier what we did, 7-8 questions, they're kind of mandatory because they were really easy. All right, it would be sad if you don't notice them. Right, these questions you have a choice based on your strengths and weaknesses. One of you, some of them may do trigonometry, one of you may do or some of them might have done the probability. That depends what they do, what they don't do. It's kind of depends. Okay, let's take a look at this. Cos square pi by 8, cos square 3 pi by 8, all this stuff, right? So there is a pairing. This goes. These are the complementary pairs. You may say that what is complementary pair? Look at this. There is a pi by 8. There is 7 pi by 8. Put them together. It becomes a pi. It becomes a pi. Pi by 8 plus 7 pi by 8. It becomes a pi, which means these are the complements. Similarly, these two are complements. 3 pi by 8 plus 5 by 8. You may say that, hey, there is some cos square also here. No, I'm just only looking from the angle perspective. Pi by 8 and 5 pi by 8, right? Technically becomes what? These two put together becomes another pi. So therefore, that's the opening thought for this particular question, maybe, right? Okay, let me work with these two fellows first. Let's see what does it mean to us. Cos square, 7 pi by 8. 7 pi by 8 can also be written as cos square. It can also be written as cos square pi minus pi by 8. Pi minus pi by 8. You may wonder from where you got this beautiful thought, because we said here pi by 8 and 7 pi by 8 is pi. Therefore, out of pi, it's a complement, right? So cos square 7 pi by 8 is nothing but pi by 8's complement. I can write this. Hey, when you write this, now it becomes what? Technically, it becomes, okay, cos theta, is equal to minus cos. So if you write this as minus cos pi minus theta, right? When we write something like this, now, so when you write it, okay, cos theta, if you make it minus this one, you have to get that minus part out there. Fair enough. Therefore, you can write this as, but it's a square function. Therefore, minus of minus will become a plus function, right? Plus function, a little bit of trigonometry out here. Therefore, you say that, hey, this is as good as writing cos square pi by 8. This is as good as writing cos square pi by 8. What is cos square pi by 8? Cos square 7 pi by 8 can also be written as cos square 5 pi by 8, which means you are trying to say, hey, this fellow can also be written as cos square pi by 8. It is as good as this. Going by the very similar logic, going by the pretty similar logic, you will also understand that then cos square 5 pi by 8, because exactly same root I will take, because these two are complements of pi. These two are complements of pi. Therefore, I would exactly taking the same root. I will say that these two, since these two are complements, that is 3 pi by 8. Here, complements are what? 3 pi by 8 and 5 pi by 8. These two are complements of pi. Therefore, considering these two, I will also say, hey, this is as good as writing cos square. Very similarly, what I did here, ditto, like this. like this time I will write pi minus 3 pi by 8. Therefore this will become cos square 3 pi by 8. Right, in the exam also you take the clues like that. If I can already find out for this, so write for the other one also. You don't have to keep doing it again and again. Okay, ultimately therefore your equation has become what? Right, ultimately it has become what? 2 times of 2 times of cos square pi by 8, cos square pi by 8 plus, where is cos? 2 times, here 1 time, here another time, plus cos square 3 pi, cos square 3 pi. Right, now these are the two portions that you write. Where is 2 times cos square 3 pi by 8? Well, it now, so here, right, now this is cos square 3 pi by 8. This is also cos square 3 pi by 8. Now what about the first part? This is pi by this part in this part are similar, right? So therefore you took 2 times there, right? Yeah, from here you can also say that, hey, this 3 pi by 8, cos square 3 pi by 8 can also be written as, now listen to me very carefully, well, it can also be written as cos, well, now this can also be written as cos pi by 2, pi by 2, all right, minus pi by 8, pi by 2 minus pi by 8. You may wonder from where you are getting this idea of pi by 8, right? Because the idea is from where you are getting this idea of pi by 8, because there is a pi by 8. Right, now I'm trying to think that how on earth I'm going to get this pi by 8. How did you get this idea? Now think about this. Add these two. Again add these two. Pi by 8 plus 3 pi by 8. Isn't it 4 pi by 8? What is 4 pi by 8? Isn't it equal to pi by 2? Therefore, I'm now writing a complement of pi by 2. And therefore, I'm writing a complement of pi by 2. Cos pi minus pi by 2 minus theta becomes how much, my friends? Sine, right? It will become sine pi by 8. This will become sine pi by 8. Now let this portion has become sine pi by 8. But you said that, hey, it is a square function. Then write it as a sine square function. Therefore, you can substitute this. This has become sine square pi by 8. This has become sine square pi by 8. Hey, what was this? Well, this was cos square pi by 8. This was cos square pi by 8. How many times? 2 times. How many times? 2 times. We know this identity. Cos square theta plus sine square theta is nothing but 1. 1 how many times? 2 times. Therefore, 2 into 1, nothing but 2. Beautiful question leading down to this identity. What is that we are talking about here? The conversions, right? Basically conversion, right? So therefore, so this pretty simple conversions, but again depends on what is your strength and what is your weakness. It simply boils down to that. So trigonometry is your strength. You can work with this. Hey, trigonometry is not my strength. Probably you can park it aside because there are several issues, several other issues which can be in your favor, right? Okay, couple of last few questions and we are done, right? So I'm coming to this again. These are all choice based matrices. Yes, we all understand matrices and determinants, but then this time what it is, he mixed matrices. He mixed the matrices along with probability. In fact, all right, now he mixed matrices with counting, that is PNC, matrices with PNC to probability. Right, this is the route author has taken. Right, therefore I say that, hey, these are little intense issues. Matrices to PNC to probability. All right, now that is the route this fellow is trying to take. Okay, let's see here. So first part is what? Tracking the matrices part, because he's saying that, hey, this is nothing but, already you take 4 distinct integers. The matrix is filled with 4 distinct integers. Okay, like this matrix is filled. There are A here, there is a B here, there is a C here, there is a D here. 4 distinct. A not equal to B, not equal to C, not equal to D. Fair enough, right? A, B, C, D. All these are not equal. 4 distinct. Great. Then what is here to form? Singular. The next word is singular, technical word. If I don't understand what is the meaning of singular, then it will not make sense. Alright, you have to form a singular matrix on this. What do you mean by singular? The determinant value is 0. That is A into D, the determinant value of this matrix. This square matrix should become 0. A into D should be equal to C into B. When A into D is equal to C into B, that is when you say that the determinant value has become 0, right? Okay, so this is what you should get here. A into D is equal to C into B. Fair enough. So in how many ways it is possible? Let us try and see. First of all, how many ways you can plug these numbers A, B, C, D? Right now you have these 4 numbers A, B, C, D. A can be plugged in 6 ways because I have 6 distinct integers. B can be plugged in 5 ways. C can be plugged in 4 ways. D can be plugged in 3 ways. Say, why did we write 6, 5, 4, 3? Because they are distinct. A is different from B. Whatever the value already given for A, you cannot use it for B. So therefore you say that your denominator can be fixed in these many ways. right? These many ways your denominator can be fixed, which means because it's a probability, there is some numerator and there is some denominator, right? Yeah. So therefore you say that, all right, 4 3 times 12, 12 into 5, 60, 6 into 6, 360. Denominator can be plugged in 360 ways. Fair enough. What about the numerator? Now let's see. All right, that's where the challenge comes. Numerator is what? Singular matrix. Out of 360 determinant values you arrived at, right? Now 360 different matrix that you can create. How many of them would be singular in nature? That is what he is asking. What do you mean by singular? A into D should be equal to C into B. This is what you are trying to say. First, identify one pair, let's say. All right, now while you are doing that, so one thing that comes to your mind is 5 cannot be used. All right, 5 cannot be used. Why? Because there is only one multiple of 5. All right, 5 can never be used here, which means for the value of A, if you use a 5, let's say that you used a 5. Now you write whatever you want to write in these places. It will never be equal because there is only one value which is a multiple of 5 here, right? Therefore, it will never be equal. Fair enough. Then there are two numbers which are the multiples of 3. Therefore, both should be used. Now look at this. This is a multiple of 3. This is a multiple of 3. There are two numbers which are multiple of 3. Both must be necessarily used, right? Both must be necessarily used, not together, separately. Therefore, I will say that one leader is 3, the another leader is 6. You may say that what are these leaders doing, man? See, because one pair is A into D. There is A into D on one side, right? And there is a C, B into C on the other side, right? Therefore, 3 will be on one side and 6 will be on the other side. Which side? I don't know. If 3 is on one side, 6 should be on the other side. It's a must. Both cannot be on the same side. You cannot say that, hey, I will write 6 into 3 this side itself. No. All right, if 3 is on one side, 6 should be on the other side. It is pretty clear and obvious, right? Because there are only two multiples of 3. 3 is on one side, 6 is on one side. Now try to match other numbers. Say what can be the other ways in which you can kind of match these particular numbers. Fine. So therefore, rest of the game. So 3 and 6 have been fixed, right? So all you fixed is what? 4, 5 cannot be used. 3 and 6 have been fixed. You just have to play with 1, 2 and 4. Therefore, you are now playing with 1, 2 and 4. How do I play? I will put a 2 here, 2 and 3 here. All right, therefore, I will make it 1 and 6 here. That is one way I can make it equal. Second one, all right, second one, okay, there is 3 on one side. There is a 6 on the other side, 6 on the other side. Another way is what? Hey, I will make this 4 here. 4 into 3 is 12. And 2 into 3 is 12. You just have to play with 1, 2 and 4. That's it. These are the only two combinations done. There is no third combination. Fair enough. But how many ways you can permute this particular combination? Let me write it here. A into D is equal to B into C. Okay, what are your combinations you thought about? Let me just illustrate this. Let me just illustrate this. 2 and 3 are on one side. 1 and 6 are on the other side. 1 and 6 are on the other side. Right? So when you're writing them, 2 can be here. 3 can be here, therefore 1 here and 6 here. 2 and 3 are still here, but 6 and 1 can interchange, right? 6 and 1 can interchange, right? 6 and 1 can interchange. You may say that, hey, no, yeah, 3 here and 2 here and 1 here and 6 here, right? You may say that, no, 3 here and 2 here, but 6 here and 1 here. So therefore, you already permuted in 4 cases. Now the point is, hey, why 1 and 6 should be, all right, why 1 and 6, all right, why 1 and 6 should be the values of B and C? Why 1 and 6 should be the values of B and C? Can 1 and 6 consider the values of A and D? And can 2 and 3 take the values of B and C? Yes, in that case, you will get another 4 cases. Therefore, 4 plus 4, 8 cases. In these numbers, this set of numbers, you get 8 cases. This set of numbers, you get 8 cases. Therefore, what you are trying to say, hey, it is going to be 16 divided by 360. Right? 16 divided, which means 16 cases are in your favor. 8 cases from the first, 8 cases from the second, 8 plus 8, 16 cases are in your favor. Out of how many, friends? Out of 360. Out of 360. Therefore, you are saying that it is 16 out of 360. Simplify this 4 times, right? 4 times and 490 times. Further 2 by 45. All right, which becomes 2 by 45. Pretty simple question, right? Now, it's a longer, lengthy question, no doubt, because the concepts involved are, first, matrices concept should be clear. What is a singular matrix? All right, from there, your counting algorithm, PNC, should be clear. Then the final closure is using probability. Probability is not playing a major role here. Although the word looks like a probability on the face of it, probability is not the concern. The concern is matrices to the counting, that is PNC, to probability. All right, now that is the route it was taking. Therefore, I say that this is a deeper question. But the point is, I'm very comfortable with PNC. I'm very comfortable with matrices, you can give an attempt. See again, so who should do, who should not do depends upon, when it comes to level 2, when it comes to the round 2 questions, it all depends upon what is your strength and what is your weakness. You need to be little clear. Okay, I'm not very comfortable with matrices, singular, etc., etc., stay away. I'm not very comfortable with counting, stay away. No, I have sufficient comfort there, you got to try them. See, that's what makes the difference between the round 1 and round 2. Round 1, most of us will do it. Round 2, we have to be very clear with our own SWOT, right? We should be clear with our own SWOT. Here we are with one last question. Let's say let's take a look. Three workers working together need 1 hour to construct a wall, right? The first worker working alone can construct a wall twice as fast as the third worker. Pay attention to this, twice as fast as the third worker, twice as fast, and can complete the task, all right, an hour sooner than. So let's take, all right, now the third worker as the benchmark. There is a worker 1, there is a worker 2, there is a worker 3. Let me take third worker as the benchmark. If I take the third worker as the benchmark, let me take the first worker as the benchmark. First worker as the benchmark. He's fast, he's quicker, efficiency. First worker is twice as fast. The first worker. All right, now first worker is twice as fast, which means time taken by him. If time taken by him is going to be n hours, I'm talking about hours. If the time taken by him to complete the task is n hours, time taken by the third worker is going to be 2n hours. Why? Because the first worker is twice as fast, quick, he's twice as fast. Therefore, he takes only half the time of the other person. Therefore, if the first worker takes n hours, the second worker will take 2n hours. At the same time, he's also saying that, hey, look, can also complete. Who can complete? The first worker can complete the task an hour sooner than the second worker. He takes 1 hour less than the second worker, which implies the second worker takes n plus 1 hours. The second worker takes n plus 1 hours. If the followed, because he's saying that the first worker completes the task an hour sooner, but you already wrote this as n here. Therefore, how much time the second worker will take? Second worker will take n plus 1 hours. See, now what is the efficiencies? Efficiency of the first worker 1 by n. That is the hourly rate. What is per hour rate? 1 by n. All right, now what is the second worker? 1 divided by n plus 1. All right, 1 divided by n plus 1. What about the third worker? Third worker 1 divided by 2. 1 divided by 2n. These are the efficiencies. How long they work together? 1 hour they work together. These are the efficiency. 1 hour they work together. To complete what? One full work. To complete what? One full work. This is what they are trying to do. From here you are getting it what? 1 by n plus 1 divided by n plus 1, because first worker is taking n hours, the second worker will take 1 extra hour, the third worker will take 1 by 2n hours. This one will not make sense here. All right, now this one will not make sense. So therefore is equal to 1. Becomes what now? It becomes a quadratic equation. See, therefore it starts with the concept of time and work, but it ends with the concept of quadratic equation. See, that is where we call them as the deeper questions, because we are getting into the multiple concepts out here. Now you got into a concept of quadratic equation, right? So what is the quadratic equation? Take the LCM here. The LCM of this is nothing but 2 times of 2n times of n plus 1. This is the LCM issue that you are talking about, right? So this is the LCM issue that you are writing. All right, yeah. So continue. Therefore, you say that, hey, here it is going to be 2 times of n plus 2 times of n plus 1 plus 2n plus n plus 1 is equal to what? N. Simplify this, my friend. Simplify this, and there you are all right now with the required value of n. Once you get the value of n, you can close this particular question. All right, yeah. Let's understand this. There is 2n, there is 2n, and there is another n. Therefore, you say that, all right, this is 5n. All right, this is 5n, and there is 2 1 time 2, and there is another one here. Therefore, plus 3, that's in the numerator, which is also equal to, take this fellow to the other side. All right, you will have 2n square plus 2n, right? 2n square plus 2n. That is what you have on the other side. Take this, kick this fellow to the other side. So you will get this as 2n square minus 3n minus 3n minus 3 is equal to 0. Something like this, right? This is what you have. 2n square minus 3n minus 3 is equal to 0. B square minus 4ac. All right, try to work with that concept of b square minus 4ac on this. All right, that is roots are minus b plus or minus under root of b square minus 4ac divided by 2a. right? So this is what you kind of use. So you have the values of ABC ready. So once you do it, I'll let you take the better value for A. You may get one positive value of A. You may get one negative value of A. Take a positive value, or let take a positive value of N. So assume, all right, now, so I'm not solving this completely. Paucity of time and space. You get the value of N. Once you get the value of N, what is your required answer? Okay, what is that you are supposed to be doing once you get the value of N? So you say that first fellow took N hours, second fellow took N plus 1 hours, third fellow took 2n hours. Hey, together how many hours they took? Or let add them together. Add them together. Together they took 5n plus 1 hours. Sorry, together they took 4n plus 1 hours. Together they took 4n plus 1 hours. That's your answer. 4n plus 1 divided by 3. Now you may wonder from where I'm writing this plus 3, because he wanted the average. He wanted the average. It's an average. Therefore 4n plus 1 divided by 3. Where is the n here? From this quadratic you will get the value of n. From this quadratic you get the value of n. Go back, substitute that value of n, and there you are with the closure on this particular question. Right? Okay, I hope all it. Now this brings me to the end of all 15 questions that we did. Okay, so if you're preparing for your entrance exams, any of these BBA or CLAT, or in the space of UG, if you're preparing for any entrance exam, you want a last mile push, or we are getting into the thick of the exam season. So you want that last mile push. All right, here are some of the offerings. There are certain offerings out here. So you can get onto our website, www.endeavorcareers.com, or you can go there. You can see it from there as well, or you can take a look at this particular offerings and you can check what suits you. You can buy that. Also, already know if you are looking for the course, long-term course, or it's some online self-preparation course, or you can also log on to the website and you can try 1 week free trial on this. Right, so whatever suits you. So here we are, but we will continue to educate you on this particular platform. Watch out for the future lectures. So as we go into this particular season, we will try and bring forth all the impactful and all the important topics in front of you. So here I am, all at the closure of this. I will see you once again. Stay blessed. Bye.